everyone. In today's lesson, we're going to talk more about trig limits. So before we can actually go over the definition, I want to just review the flowchart. So in the flowchart, we're always going to try direct substitution first. If we get a number, life is beautiful, and we're finished, we need to do nothing more. If we get 0 over 0, that means we have a whole. And then we need to use one of these three trig, limit definitions. So yesterday we focused on these guys. The limit as x approaches 0 of x over sine x and sine x over x. Both of those limits will always give you 1. Today, our main focus is actually going to be on another trig limit definition. I actually just realized that there's a typo here. So the real limit is going to be this. It's the limit as x approaches 0 of 1 minus cos x over x. And this limit will always give us 0. So please just cross this one out and rewrite it with the one that I've just written below. All right, so now I'm going to explain how it works. So here we are back at the original page. Just remember that everything was copied, so this limit is actually backwards. So it's the limit as x approaches 0 of 1 minus cos x over x. And this limit will give us 0. So if you look at the picture, I have graphed 1 minus cos x over x. And if we take the limit as x approaches 0, we could see clearly that the limit from the left and the limit from the right clearly both approach this same y value, and that y value is 0. Now, if you did flip it, in the sine graph that we did yesterday, we were able to flip it. But the reason why we can't is if I had x over 1 minus cos x, that graph actually looks like this. You don't have to draw this, but I just kind of want to show you. As x approaches 0 from the right, it goes up. And as x approaches 0 from the left, it actually goes down. So technically, this limit does not exist. So that's why we can't flip it like we did with the sine one. So this is the only one that we can use. So the limit as x approaches 0 of 1 minus cos x over x. So this one doesn't work. All right, let's do a couple of examples. So I'm just going to write the definition on top so I know what to look out for. So we have the limit as x approaches 0 of 1 minus cos x over x. And we know that that limit is equal to 0. So if we look at example number 1, we're going to first try using the flowchart direct substitution. So I'm going to go ahead and do that first. So 1 minus cosine of 10 times 0, right, because the limit as x approaches 0, over 10 times 0. So if we simplify this, it's 1 minus cosine of 0 over 10 times 0, which is 0. So if I want to find what the value of cosine of 0 degrees is, I need to make a unit circle, which we'll use. And I only care about this spot because this is where it's 0 degrees. So this point on the unit circle is 1, 0. So this is the point x, y. Remember, cosine is the x value. So cosine of 0 will be 1. So if we keep simplifying this, it's 1 minus 1 over 0. So that will be 0 over 0. Now, just for purposes of space, I'm just going to write this here as 0 over 0. So that gives me a whole. So now my second step is going to be to simplify this so that I can use one of these limits up here. So step 2 is going to be to do a little simplification. So I'm just going to go ahead and rewrite the problem. So we have 1 minus cosine of 10x over 10x. And you should actually notice with this one, we don't have to simplify anything Because if you remember from the other day when we did sine, as long as what's inside these parentheses is the same as the bottom, then it's equivalent. So 10x over 10x, this limit is actually just going to be 0. So the limit is 0. No work necessary. So no work needed because there's a 10x on top and the 10x on the bottom. So like I said, these x's need to be the same. It could be no matter what it is, 10x, 12x, 13x, the answer will always be 0. All right, let's try another example. So example number 2, we're going to do the same thing as example number 1. We're going to try direct substitution first. So we have secant of 0 minus 1 over 0. So the bottom stays as 0. And now we have to find secant of 0. So we know that secant is the reciprocal of cos. And we know that cosine of 0 degrees is 1, right? Cosine of 0 degrees is the x value, right? X value, so cosine of 0 is 1. So if I want to find secant of 0 degrees, I just need to flip 1, or flip 1 over 1, which flips to 1 over 1, which is 1, right? So secant of 0 is 1. 1 minus 1 is 0. So we get 0 over 0. So now the second step is we're going to have to simplify this fraction. And the goal is going to be to have it look something like this. And I really have no cosines in this problem, so what I can do is know what secant is equal to and rewrite it. So I know that secant of theta, or secant of x, is 1 over cosine of x. Then I'm going to subtract 1 all over x. So all I did was rewrite this secant as 1 over cos. And then I brought down the minus 1 and the x. And now I can try to simplify this equation. So if you remember, when we add or subtract fractions, right, this could be 1 over 1, we need a common denominator. So I'm going to multiply the top and bottom here by cosine of x. So my denominator stays as x, and my numerator is simply 1 minus cos x all over 1 singular cos x. Remember that when we subtract fractions, we subtract the tops, 1 minus cosine of theta, and we keep the denominator the same. And now I have one fraction divided by another, and technically that x can be written as x over 1. So we're going to keep change flip. So we're going to keep the 1 over cos x over cos x. We're going to change the division to a multiplication, and we're going to flip the 1 over x. All right, so now the idea is going to be to manipulate this so that we could get it to be what I need it to be. So we can actually put this numerator over this denominator, and then we can put this numerator over this denominator, right? Multiplication is commutative, so we could switch the order. So we can do 1 minus cos x over x times 1 over cos x. And this you should recognize as a limit. We can take this limit as x approaches 0, and we know by definition that this limit here is 0. So now we're doing those rules where we're taking the limit of each piece. So I'm taking this piece as the limit as x approaches 0, and I'm taking this piece, the limit as x approaches 0. This one happens to be a definition. 1 minus cos x over x is 0. And then this one, we're going to directly substitute 0. So 1 over cosine of 0. And if we go back to our unit circle, right, cosine of 0 is the x value, so it's 1. So back in here, it's going to be times 1 over 1. So 0 times anything is just 0. So yeah, all that work for one problem just to get back 0 at the end. It's unfortunate, but that's what we're going to have to do to get this answer. All right, let's try another one. All right, so problem number 3, we're going to do direct substitution first. So I'm going to go ahead and plug that in. So step 1. So 1 minus, now remember, cosine of squared theta is the same thing as saying cosine of theta, that whole thing squared. So 1 minus cosine of 0, that whole thing squared. Theta is 0. 1 plus cosine of 0. So at this point, you should really know that unit circle very well. So cosine of 0 is still the x value, so it's still 1. So when I do direct substitution, I'm going to get 1 minus 1 squared over 0 times 1 plus 1, right? Because cosine of 0 is 1, cosine of 0 is 1. So the top is 1 minus 1, which is 0, and the bottom is 0 times 2, which is 0. So we get 0 over 0. Everything is good. So now our goal is going to be to simplify this so that we can use our limit definitions. So I'm just going to rewrite it. So the limit as, I'm using x, so let's say as theta approaches 0, 1 minus cosine squared theta over theta 1 plus cos theta. Now, the way we simplify this one is actually really funny. It's kind of unique. We can use a method called factoring, but we could factor with trig. So think about, just as a commercial break for a second, if I had x squared minus 25, we all know that that's dots, right? X plus 5, x minus 5. Even if I had 1 minus x squared, we know that 1 is a perfect square, so we could break that up into 1 and 1. And we know x squared is a perfect square, so plus and minus, right? So we actually can do the same thing here with the numerator. This numerator here, 1 minus cosine squared, is in fact the difference of two squareds. So if we want to break that up, we can break it up into 1 and 1 to give us the 1. And then we can break up cosine squared into just cos times cos. And then a plus and a minus, just like we did with these dots problems. And then I can divide this by the original theta 1 plus cos theta. And you should see that these 1 plus cos thetas are the same, so they actually cancel. So we're left with 1 minus cosine of theta all over theta. And we want this limit as theta approaches 0. Now you should recognize this. This is your rule. 1 minus x, 1 minus cos x over x. So this limit is nothing other than 0. And that's the work that we get to. Or how we get there, rather. All right, let's try one more. Let's try example number 4. So I want to take the limit as x approaches 0 of 1 minus cos 3x over x. So again, just like we did before, we're going to do step 1, which is direct substitution. So we've got 1 minus cos of 3 times 0 over 0, which is 1 minus cosine of 0 over 0. And from before, we know that cosine of 0 is 1. So it's 1 minus 1 over 0, which is in fact my 0 over 0. So now we need to use some rules. So I'm just going to, as step 2, I'm going to rewrite this. So we have the limit as x approaches 0 of 1 minus cos 3x over x. Now from what we said before, if there was just a 3 here, right? See how there's a 3 here and a 3 here? We actually could have made that work if they were the same. So that's actually all we need to do to get this answer, is that we need to multiply this bottom by 3. So to not change the value of the function, we need the top to be a 3 as well, because 3 over 3 is 1. And then we can do what we did before, is manipulate it, because multiplication is commutative. So we have this 1 over cos 3x that I can multiply on the bottom, these two, right? 3 times x is 3x. And then I can make this one separate. So we're going to rearrange this as 1 minus cos 3x over 3x, then times that lonely 3. And we're going to take the limit as x approaches 0. And remember, we could take the limit of each of the pieces. So this whole limit, by definition, is 0. And then when we take this limit as x approaches 0 of a constant, that limit is just the constant. So that limit is 3. So 0 times 3 is not 3. 0 times 3 is 0. Now, you're going to notice a lot of these problems, the limits were 0. And they're like that because, you know, this, when you multiply anything times that 0, you're going to get 0. So that's why that happens. It doesn't always happen that way, so don't always assume that. But yeah, so those are the 4 problems that I have for today. So take a couple minutes and jot down any questions that you have. I know this is a particularly challenging topic, so don't stress if you didn't get it. We will go over the rest of this more in detail tomorrow. All right, have a good night.